In this video, we'll be looking at mean and the variance of a binomial distribution. If x is a binomial random variable with x has a binomial distribution of n and p, then the mean of x is n times p. So we know from statistics 1 that we can denote the mean as expected value of x, and the mu, which is the population mean of this random variable, and the variance expected value, or sigma squared, and p times 1 minus p. N is the number of trials, p is the probability of success, and the 1 minus p is the probability of failure. Let's apply these rules in an example. A fair five-sided spinner with a segments numbered 1 to 5 is spun 20 times. The random variable x represents the number of fives obtained. The mean and the variance of x we need to find. Also, we need to find the probability of x, which is less than mean minus standard deviation. Alright, to do this, we need to first define the x. X is a binomial distribution. I mean, let's say x has a binomial distribution. Let's say x has a binomial distribution of 20 trials. That is the fair five-sided spinner will spin 20 times, and the numbers on it is 1 to 5. That means probability of getting 5 is 1 over 5, because we have 5 sides or 5 faces or segments, and that's a fair spinner, so the probability of getting 5 is 1 over 5, so as the others as also, and we're talking about getting a 5 because they say 5s obtained. So that's basically x is representing the number of 5s. Okay, so the solution for the part A, it says the mean and the variance of x. So the mean of x, that you can write mu as well, is going to be 20 multiplied by 1 over 5, which is going to be 4. So the mean number of obtaining 5s will be 4. And the variance of x, write in a different form, is the np multiplied by 1 minus p, where n is 20 and the p is 1 over 5, and that's multiplied by 1 minus 1 over 5. So it's going to be 4 multiplied by 4 over 5, which is 16 over 5. So the mean of, variance of obtaining 5 is going to be 16 over 5. This is 3.2, or you can keep it like so, or you can write it 3.2 by dividing 16 by 5. This is part A. We need to calculate the mean and the variance of x. In the part B, we need to calculate the probability of x being less than mu minus sigma. Alright. To do this, we need to know what is mu. We already worked out the mu. Mu is equals to 4. That's the mean. Sigma, on the other hand, is the square root of the variance. Right? Sigma standard deviation is basically we calculated on the second one, the variance sigma squared, as 3.2. If I take the square root of sigma, I will have the standard deviation. This is approximately, you can use your calculator to work this out. This is approximately 1.789. 1.789. So in the probability, you will be put probability of x being less than mu 4 minus the standard deviation, which is 1.789. It gives us the probability of x being less than 4 minus 1.789 is going to give us 2.21. Alright, so you can consider this as 2.21 as the x is the discrete random variable. Well, remember the x is represent a number of 5 obtained. So this one says basically x is gonna be being 2 or less. 2 or less, because we can get either 2 5s, or a 1 5 or a non-5. Okay, so x is being less than 2.21 means x is being less than 2 because we are talking about discrete random variable. Remember the discrete random variables, or just remember the type of data which is discrete, which must be precise. Okay, so all we have to do now and go to the table. The probability is being 0.2 and then n being 20. So you need to go to the table, the n being 20, find that, and then probability is being 0.2. So x is being less than equals to 2 is going to be 0.2061. So that's from the table. That's example 1. Let's see one more example. Example number 2. It says a company produces a certain type of delicate components. The probability of any one component being faulty is P. The probability of obtaining at least one faulty component is a sample of 4 components. In a sample of 4 components is 0.3439. So we know the probable component being faulty is P. Obtaining at least one faulty component is in a sample of 4 is 0.3439. Company produces 600 components in a day. 600 components in a day. Find the mean and the variance of the component number of faulty components produced per day. Alright. So let's define a random variable binomial x or y random. Let's take this time y. Y has a binomial distribution of n and p. Okay. So remember we have given a statement as the probability of obtaining at least one faulty. So at least y is the number of faulty components. At least one component, so which is bigger than or equals to 1, is equals to 0.3439. If you want to understand the reason behind that I'm writing, just read the part that I highlighted. Okay, so we just took the being a faulty component, probability of being faulty component is P, and n is the number of trials. As you can see, they are talking about this, the taking at least one being faulty of a sample of 4. Okay, so for this scenario the n is going to be 4. Okay, so probability of y being greater than equals to 1 can be written as probability of let me write it like this. 1 is 1 minus the probability of y being basically less than 1. Just gonna say just equals to 0, right? Y being less than 1 is just y0. So if you just take the y being 0 out, so everything else comes after that will be the what we want. Okay, so that is basically equals to 0.3439. So So that's going to be 1 minus, out of 4 trials we want, out of 4 we want 0 being faulty, and probability p to the power of 0. So in our case, successful events is basically successful events being a faulty, and 1 minus p to the power of 4 is equals to 0.3439. So that's a binomial formula that we're using to find the probability of having non-faulty components, zero faulty components. Okay. So basically, if you calculate this, 1 minus, you can calculate this as a 4 factorial divided by 0 factorial multiplied by 4 minus 0 factorial, which is basically 1. P to the power of 0 is 1, and then we're gonna leave there p minus 4 to the power of 1 minus p to the power of 4 equals to 0.3439. You don't have to necessarily write this part, which I did it only because I want to show you that's 1. Okay, so that's going to be 1 minus p to the power of 4 equals to 0.3439. So the 1 minus p to the power of 4 equals to 1 minus 0.3439. And use a calculator to calculate this, and that's basically, you can write this like 1 minus p equals to the 4th root of 1 minus 0.3439, and the 1 minus p is equals to, if you calculate that, it is gonna be 0.9, and you can say that the probability is going to be 0.1. Probability of being faulty is 0.1. Okay, now we need to define a new variable, because remember the b in that one, y it was being representing to 4 faulty components when the probability of is 0.1. Okay, so that's in the second one, company produces 600 components in a day. We need to find a mean and variance. So it's basically, we will be taking x has this time binomial distribution of 600. So obviously the same company producing the same products, probability of being faulty stays the same. So if I'm looking for a mean, so that is a 600 times 0.1 n times p, which is going to be 60. So the mean of faulty components in a day is, we are expecting that's going to be 60. And variance is the np multiplied by 1 minus p, which is 600 multiplied by 0.1 times 0.9. That is going to be 54. That's the variance. And they were asking for variance and mean. So if they want for standard deviation, we'll be we'll be taking a square root of 54. Alright, so that's the one. For this second example, we should be working out the value of p, which is the probability of faulty components, which we did it using the information given in a sample of 4, at least being a faulty probability of 0.3439. And then the company produces 600 components in a day. We need to find the mean and the variance. We defined a new variable x random variable, where binomial distribution 600 trials 0.1 in a day. So we found the mean and the variance of that.